Hello, I think we are live, Darrell, right?
Yes, we are live. Welcome everyone to our webinar on the Wingtra and its solutions and survey and mapping. Um, I'm Darrell Thibbles. I work with KOREC for about 15 years, and I've been flying fixed wing and rotary drones for um, about since 2012. With me, I have Lorenzo. He's from Wingtra, and he will be introducing you to the Wingtra product and its capabilities, accessories, etc. So over to you, Lorenzo.
Fantastic. Thank you very much, Darrell. So very excited to be here with KOREC to introduce you to our system and our latest payload, which is a LiDAR sensor. If we go next, Darrell, could we please? So first of all, a quick overview of Wingtra. It is a Swiss company based in Zurich, founded in 2017. It now has more than 170 employees and a global footprint with more than 90 distribution partners. If we move to next, Darrell, which is what we set out to do at Wingtra, is to offer one integrated solution for sustainable and efficient asset management. So what that means, is a constant focus for us to be able to offer our clients a solution that's increase their efficiency in collecting data in the field. It provides high quality outputs and data, and also is very easy to use. So we are doing this across a variety of industries, from airport maintenance assessment to road construction surveys, mine surveys, environmental monitoring use cases, tree counting, wildfire damage assessment, as well as ag applications. And how do we do that? Well, we offer a VTOL drone platform. As you can see, VTOL meaning that has a vertical takeoff and landing capabilities. So we are able to mesh the flexibility of operating from confined spaces with the efficiency of flying in fixed wing mode, and so being able to cover very large areas. The system comes with a tablet with a ground control station software called Wingtra Pilot app, where you can plan the mission and control the aircraft while in the field. There is also a desktop version called the Wingtra Hub, which allows you to plan the missions in the office. So then you can just focus on collecting data when you get to the field, and maximize the efficiency in there. So you just rock up, set up your system, load your mission, and press go. You can do that with a variety of sensors. We have RGB cameras, multispectral sensors, and also a LiDAR sensor now. The software that we offer with the RGB cameras allows you to geotag the images and then take those into your photogrammetry software of choice. For example, it could be a Trimble Business Center. And with the LiDAR, we offer a Wingtra LiDAR app, which will provide you with a point cloud and last file that then can be taken into TBC, for example, for interrogation of the data as needed by your project. It could be region classifications or other points, which also Darrell will explain in more depth shortly. And if we look at the aircraft itself, it is engineered and assembled in Switzerland. It has a built-in PPK GNSS receiver, so allows you to get really accurate geotags or positioning of your drone via the setup of your local base station or leveraging the course network. It is a C3 certified drone, so it has an integrated remote ID. It is, in line with the latest regulatory requirements for operations in Europe, and also offers automatic safety checks, which really simplifies the workflow and the health check of the system before you start operating. And now, without further ado, let's have a look at our LiDAR payload. Darrell, I think the audio might not be coming through.
Let's try again.
The fastest mapping drone just got Lidar. Bring efficiency to the next level. No calibration needed. Start mapping with a quick 1-minute initialization. Cover up to 360 hectares with every flight and process the data you need on the same day. You've never mapped so fast. Get high accuracy terrain reconstruction even under dense vegetation. Trust that your projects are built on the most reliable information. Thanks to high quality, strip aligned data capture and a user-friendly Wingtra app, anyone with a little experience can get the needed insights right away. Switch payloads as you need and keep a lean fleet. This is your one tool for total terrain intelligence across construction projects. Wingtra Lidar. It's efficient, easy to use, and reliable. Hear from our satisfied customer. From a timing perspective, with better results, it takes less time with the Wingtra. The fastest mapping drone just got Lidar. Contact us now and start mapping faster.
Excellent. Can go to the next. All right, so the question now is why a Lidar on a Wingtra? So we are focusing on 3 main points. Basically because it can offer, we can maximize the efficiency of your data collection. It helps you to get reliable insights consistently, so high quality outputs, and also you can benefit from a very simple workflow. So when we're talking about maximizing efficiency, because of that capability that I mentioned before, we have fixed wing aircraft but a VTOL, so we take off and land vertically, but we fly in a fixed wing mode, so we can cover a very large area. If we fly at 90 meters above ground level with 30% side overlap, we can cover 360 hectares in one flight. Also, another point that's for maximizing efficiency is the fact that there is no calibration required. And so, Darrell, if you go again to the next step, no calibration required. Basically, it means that the system still does the calibration, but there is no need for manual flying in, drawing figure eights in the sky or anything like this. It's done automatically during initialization, which is very quick, and also transition to the mission. Reliable insights, meaning that we can achieve a 3 centimeter vertical accuracy, which is a figure that's leading in the industry, especially within this weight class. And the simple workflow, meaning that there is exceptional strip alignment thanks to the integration of the components of this payload, which we'll have a look in a second. You get a seamless workflow in terms of getting strip alignment completed. And a simple system to use means that you spend less time in learning, getting familiar with the system, but you can get up and running really fast, start collecting data. That's the advantage. Why we introduced the Lidar payload? So we're very excited. We've been working with photogrammetry for many years now, and photogrammetry allows our users to collect data across 60 to 80% of the phases of their projects, especially if you look at construction. But we have seen that there was a need for our clients to also capture data below vegetation, and this is typically done in the planning phase of the project, and that's where the Lidar is closing the loop in the ability of your ability of collecting data in all phases of the project and add value throughout the cycle. And next, so we do this with this system with the Lidar, which as you can see from the image, will allow you to get terrain data from underneath the vegetation. And to do that, we have a 3 centimeter accuracy, vertical accuracy offered, very easy to use, as I mentioned before, and also the efficiency of being able to cover like 2 to 3 times more area coverage than competitors available in the market, operating in the market. If we go next. So having a look at our payload, as you can see, we have 3 main components. We have the HSI LiDAR scanner, which offers best precision and range within this weight class, together with the IMU module provided by Inertia Labs and the Novatel GNSS antenna as well. And we took this and we are integrated with our system, the WingtraOne, that then offers you a tested, ready to go tool that it's easy to use and allows you to capture consistently high quality data. We go next. A quick overview of our workflow. So as you can see here, with Wingtra, you basically complete the first line of this slide. So you plan your mission. This can be done again in the office with the desktop application and be safe. You just go to the field, unpack the drone. It takes only a few minutes via the tablet. You upload the mission to the drone. You run your self-check. So again, everything, the checklist is guided through for the operator. Then you press go and you start to collect your data. And if you look at there, for example, like in 30 minutes, we cover 250 hectares. And so you cover that in only half hour. Go back to the office, use the Wingtra LiDAR app to do your trajectory correction, and then generate a point cloud last file that then can be exported into your preferred third-party software. So it could be Trimble Business Center or LiDAR 360 in this case. And when you can also interrogate the data as needed, multiple options where Darrell also will explain more later. We can go next. So I mentioned before that we have been in photogrammetry for many years now, and the LiDAR is the missing link. So in this full cycle, let's say, of data collection over a project, RGB also is very important, an RGB sensor. And at the moment, our flagship payload is the RGB 61, powered by Sony, and which allows us to cover, again, going back to that efficiency, up to 310 hectares in one flight, flying 120 meters above ground level, and benefiting from a GSD of 1.9 centimeters. So the advantage of this payload compared to our previous flagship payload is the fact that we have an improved image quality, as well as having more megapixel. And we're also mounting a 24 millimeters lens rather than 35. So what it means that we have a larger footprint per photo, which allows us to cover an area faster because we need less photos to cover a certain area. So we can collect data faster in the field. And once we get back to the office, we have less photos, less images. And so that means our raw data is smaller, and therefore also the processing time is faster, compared to our previous payload. So you are faster in collecting data in the field and also faster in processing it once you get back to the office to get your outputs. So closing the loop here, we're looking at LiDAR and RGB. And so having the ability to have both sensors on your drone, it means that we say you keep a lean fleet. You have one tool that gives you very high quality data. It's easy to use. In the case of the LiDAR and the RGB camera, it's operate exactly the same. It's just a matter of selecting the right sensor via the Wingtra pilot app on your tablet, or when you plan in the office with the Wingtra hub, and then selecting the mission parameters, and then you're good to go. So very easy to use, accurate, and you'll be able to collect data from the planning phase of your projects throughout the whole life cycle of that project as well with the RGB camera. With LiDAR, you also have other applications that we're happy to discuss individually if you like, for example, environmental with forestry. So also there is an opportunity for you to increase the use of your system with this additional payload. Okay, so as I mentioned before, we've dedicated in providing one integrated solution. So we really think that the mixed link with the LiDAR will offer a ton of value to our users. And so, yeah, don't hesitate to reach out to discuss more. And now Darrell will take us through more in depth on the data processing workflow.
Okay, thank you, Lorenzo. In this section, we're going to focus on the Wingtra application to surveying and mapping, looking at the various deliverables and how from the outputs we can obtain what we need. I may go over some of the points that Lorenzo mentioned, looking at the payload, looking at the process in which you get the deliverables out. But I'm going to show it in relation to, our Trimble product, TBC, how you take these outputs and you create real world deliverables from them. So why use a drone or why use the Wingtra? In the past years, we have seen the benefits of UAVs for inspection, surveys, and mapping. These benefits provide real-world solutions. We see this in its cost effectiveness, in its efficiency, accessibility, high resolution images with the RGB 61 and the Lidar sensors. It's flexibility, so they'll be able to use drones, having you have a power lift drone as well as a fixed wing. So you have the hybrid flexibility in the product, and real-time data. You have data in an hour after flight or 2 hours after flight. You have proper data that you can use and you can create your deliverables from. We now have examples. We now have examples of these benefits in areas such as airport maintenance, quarry and mining operations, stockpile and volumes and reports, road construction, topo surveys, vegetative control, vegetative surveys, agriculture, and the list goes on. These are all produced as a result of the deliverables from the UAV or from the drone. So you do get your point clouds, which you get in LAS format or LAS format. You have your offer mosaics where you can digitize from and pull out your various assets. And there you could upload into cloud servers, and you see a proliferation of a lot of cloud services now where you don't have to rely on the processing power of a computer. And all these, you have the DSMs. You can create your DSMs and mesh. So these are the standard outputs from most of these photogrammetry software packages. So you get your LAS, your orthomosaic, your mesh, your digital surface models. These are the standard outputs from there. We've been so with Wingtra, why KOREC and Wingtra? So we've been selling drones since 2012, and we have sold a combination of fixed wings and rotary drones. We have always sold a solution. The drones was always part of the KOREC solution. We started a partnership with Wingtra in late November 2023, and we got our Wingtra wing in December and our Wingtra Lidar sensor in February. Since then, we've worked to build a complete solution with the Wingtra product, and part of this, part of that solution depends on the hardware that's provided by Wingtra. So when you get your Wingtra kit, you have everything that you need in that package. You get your tablet, your telemetry cables, your spares, propellers, etc. Part of this solution is the hardware, and you get your soft case, your soft case, which allows you to carry the Wingtra on a backpack. So if you're working in the Highlands of Scotland, looking at peat, for instance, you can carry your Wingtra with you to these sites, and it's transportable. You also get a hard case for shipping. So if you have overseas jobs, you can carry it that way as well. And then obviously you have your selection of sensors, which all come in a nice Pelican case. And comes in a Pelican case. Part of the Wingtra, as Lorenzo mentioned, was the workflow, and we found that the workflow was very easy, very user friendly. The steps were easy to follow. Training, I had one set of training in December, and from then I was able to do several flights after that, accomplish good flights using the hardware and the software. So for photogrammetry, we had the flight planning software, which you can get Wingtra Pilot, Wingtra Hub. You have data capture, where you use Wingtra Pilot to fly the drone and to collect the information you need. And then you have the data processing, which is in Wingtra Hub, and then you will export that data and process it in software packages like Pix4D and Trimble Business Center or or any of these photogrammetry software packages. So that's for your photogrammetry solution. You then take that data, and then the customer would usually take that data and put it into a data analytical software package. So you bring in your enforce, etc., to produce your deliverables, the data that's what is valuable to you and what is valuable to your customer. The LiDAR workflow is very similar. You do have your flight planning. You select your sensors. You also have your same data capture process, where you use the Wingtra Pilot, and then you choose your source of correction, which is PPK or OSNet. But for the data processing side of it, you will be using the Wingtra LiDAR app. And then you take that data, the outputs from that, and put it into your data analytical software package. You know that? Minor glitch. So every step in the workflow is important, and Wingtra has provided applications to facilitate that. So these free applications, they work hand in hand. And so, for instance, the Wingtra Pilot, this app sits on your on the tablet or the ground control station that's provided with the unit. But you also have the ability with the Wingtra Hub as well to plan your flights and then export that to the tablet if you want to work from the PC to develop your flight plans, etc. The Wingtra Hub also serves as a tool for doing your geotags and your PK processing as well. But for the LiDAR sensor, it works slightly differently. That you use the LiDAR sensor to do your PPK processing, your strip alignment, and export that data out. So an essential part of the workflow is the precision. So you need some type of correction, and that's important. That makes your data valuable. The precision is to obtain this, you need to have some sort of a base station or ground control available. Now we do so these are signs of some examples of receivers that can be used as base stations with us, and a setup of a base station, and then also you have the ground control. But in addition to that, you can log into the Trimble VRS Now network and download the course data at your 1 second interval, and then use that data to correct your points, depending on how far away from the base station that you are. One current solution that we at KOREC provide for PPK apps for PPK processing is the Trimble DL data logging application. So this is a really efficient and cost-effective way of using a base station and getting base data. It simply works by downloading the application, the DL application, the data logging application, onto an Android device, a smartphone. It's a free application, and then you simply Bluetooth that to your receiver, and you're able to do some fast static or static GNSS recording, and then export that T04 file to yourself, and the way you can then convert that to RINEX data, RINEX file, and use it for your base station processing. So a very economical, quick way of setting up your base and getting all the information without having the software. All you need is the hardware and your VRS license, etc. So in this case, we're using the software we're using our base station, we're using our correction with Lidar, a Lidar receiver. Now, from the Wingtra site, I got this definition of Lidar, because everyone needs to understand what Lidar is and how it works, and So they had the definition I saw there was the Wingtra Lidar solution enables servers surveying under vegetation by emitting rapid laser pulses to map land, which was impossible with photogrammetry. By sending out laser beams and measuring the time it takes for the light to reflect from the object, Lidar creates detailed three-dimensional. So what it is that Lidar is an active remote sensing thing. It sends the energy, it has the energy, and it sends the energy out to your various objects, refracting from this and feeding and reading and taking the measurements. Whereas photogrammetry is a passive system where it relies on the refraction of light of objects from daylight and that refracting back into the lens. So what that means is that photogrammetry actually calculates. There's a lot of calculation in order of your overlap, refraction, etc. And that takes up more space and takes longer time to process. Whereas Lidar takes direct measurements and the files are much smaller. So these are the difference between the two, and this is why you get the faster processing in the Lidar data. So data processing with the Lidar. So when I did my first set of flights and I got our Lidar sensor and we started processing, etc. After the flight was completed, the raw data is stored on a USB stick in memory stick in the Lidar. You simply take that memory stick out and you download the data from it, which is a raw file, and it's stored in a Wingtra flight project folder. That data, you then open it up in the Lidar app, and it comes in raw. So from the time when you put your Wingtra on the ground, you switch on your Lidar sensor. It begins to initialize within a minute, and then after that, so while it's initializing, after the minute, it starts scanning instantly. From then you take off. So while you're flying, it does its turns to the various waypoints and it comes back. All during this time, it's recording data. So in the Wingtra Lidar app, you are able to cut off these areas or the data that's unwanted. So what we did was just simply to the start and the end point of each Lidar of each flight length, and then that cut take off the information in the turns, etc., that you don't really want, and then you do this until you complete. You have your Lidar file now as processed with the base station. So all that at this point as well, it also asks you to put in all your base data, your base station information. So the height of the antenna, the type of antenna you use, etc. You set your coordinate system in there as well, and then you export the data. You have various choices so your export, it only exports to last file. You get a single last file or multiple last files, or you export to one LAS last file, LAZ file. Okay. From then now your your LiDAR data, your point cloud is ready, you then choose your software package that you're going to be doing your classification in, and how you'll be able to depending on the deliverables that you require. In this case, we'll be using the Trimble. I use the Trimble Business Center, and in this project, which is the hunting and race course. So a couple of weeks ago, we had our drone days where we flew over various. We had it in different sites, and this is one of our sites, the hunting and race course, where we flew, and we did a flight of covering 13 hectares. The flight time was about 40 minutes with the LiDAR sensor. The point cloud density was 183, and the point cloud size was 470. The same flight I did with the photogrammetry or the RGB camera was about 3 gigs or 4 gigs, 3 point something gigs. So you could see the difference in the size of the files there. The processing for this took about 10 minutes in the Wingtra LiDAR app, and these are the deliverables. This is what we got out of it. So in this case, as I said, I use the Trimble Business Center application. So Trimble Business Center has a module which they sell currently, which is called the aerial survey module. And that module is mainly for your photogrammetry. In there, you have your survey adjustments, your card drafting, surface alignments, UAV data processing, and point cloud. So everything that you need to be able to provide the key deliverables or the most common deliverables that I would say a lot of our customers require. To do this, all I did was I took the LiDAR file, created a project in Trimble Business Center, set the correct coordinate system, which is OST, British National Grid, OSTM2. I imported the point cloud, the LASM point cloud, but then I also imported the checkpoints. So I did some checkpoints for the LiDAR because obviously you need to ensure that your data is accurate and it's meeting the specification for your clients. So for the ground control, I did some checks. So I used the measure tool in TBC, and all my points were below 3 centimeters. So I got GCP5, GCP4 as well. They were all within the tolerance of what Wingtra claimed and what the sensor was able to provide, which is up to 3 centimeters. So this was I used the point cloud tools classification by ground and building poles. So I use this to classify my point cloud. There's also in the software, there's also customized classification in there as well, where you have a machine learning tool where you can create additional classifications, which is pretty handy, and it's available in the latest version of the module. So after classification, I use the outdoor terrestrial classification option in the module, and then I refined that as well, and I came up with the following outputs, which you can see here with your trees, your power lines, poles, roofs, your dividers. So there were loads of railings loads of railings at the race course as well, where you walk through, etc. So I was pretty satisfied with what I saw, and I compared that with so this is the point cloud there for the race course and the point cloud. So I compared the two of them and say, okay, that and that was very little. I did very little cleaning or I mean, there's a lot more that I can do, but it suited the purpose at the time, and I was pretty satisfied with what I saw. So with that LiDAR, what I did was as well, what I wanted to do, I wanted to compare the classification I did with the photogrammetry. So I did classification with a photogrammetry point cloud, and I did classification with the LiDAR. I then also looked at the surface. So I created a surface model. So this is a surface model using the photogrammetry point cloud surface. As you could see, you have a lot of spikes in there. I did some flattening as well on that photogrammetry in order to try and remove as much as I could automatically. And then I did one using the Lidar data. So as you could see, it's more defined. Even my elevations at the top, on the top here, you could see better, you get a better results for your elevations and heights and definition in there. So on a whole, this is an image from the Lidar. You could see there's a bridge in there, and in the previous photogrammetry, you cannot make out this bridge in between here as well. So the result was satisfactory, I would say. I looked at the photogrammetry, so also did a slice, a profile of it as well, a slice, sorry, through, and looking at the photogrammetry surface, you could see the bumps and the noise in the surface across that train here. But in the Lidar, you could see it's more reflective of what the actual surface is like. So I also one of the things that's important as well, I get a lot of questions on as well, how many points you get under trees. Is it actually giving you sufficient data under the tree canopy? And this demonstrates that. So here is the ground, the Lidar point cloud of just the ground surface, and then you can see whereas if you look at here now, this is the photogrammetry one where you see the trees you can't find any. There's very little points under the trees or area. So this way now, true, this area is fairly flat, so it's an open field area. So I mean, but if you're working in a forest or a heavy forested area, this is when this really comes into play. You see the benefits of the software. There you go. Also, you have the so here's an example. So if you look at this area here, and then you have this is the Lidar image. So you could see it's very good. Another point, I also did a profile as well through the trees to see exactly, okay, what does this mean? How does it compare along the line of the heavy canopy area? You have so here's the profile. So here's a profile of the RGB. You could see the ground related to the trees, etc. And then you could see in the Lidar how the area compares. So here you have very forested area here, heavy canopy area here, and you can see that you have a very good. And that was the one. So as you notice, the settings are the same for both surfaces, and looking at the two of them as well. Another area that I think is very useful especially for the GIS and mapping and surveying tools. We want to do the Lidar data collection, but we want to take that information and then put it into a GIS to go out and find the features, to do some maintenance, or to just basically make your topographic map as well. So what we use there's also an extraction tool within the application as well, within the Trimble aerial photogrammetry module. What we did was we loaded the FXL file, which is the codes from the logger, which you go out and do your topos with. We loaded that feature codes in, and then what I wanted to do was identify all the trees. So I wanted to know how many trees were there on this site, and just do a tree count, and maybe have a single point feature for these as well. You could do the same with curbs, with poles, with street lights, with various features, types of crop as well, types of trees, tree types, etc. Sorry. So all I did was that I loaded the tree code, the feature code, selected the tree extraction type. I put in I got it to do an automatic extraction, put in various controls in there, etc. You can add things like the height, the elevation, the size of the trunk, etc. There's a lot of things you can do, and then what I did was I run that extraction, and it went through, zipping through all the trees that were on the point cloud trees, and then it came up to me. It's okay. You have 125 points with feature codes, etc. And then I was able to get all of these trees extracted as single points. You could then take that information, give it to someone to go out and find these points and survey them, etc. Okay, so a very handy tool, as I say, with this one set of data set, there's so much value in it because of the classification and because of the level of accuracy that you were able to obtain. Another common use of drones would be to do things like stockpile surveys, looking at volume calculations on quarry size, and the Wingtra is a very handy tool for doing that. One first thing was because of its VTOL capability, the ability for it to take off in a tight and confined areas. So a lot of quarries, the site is always moving. You can utilize it for that. And so this was on that same Huntington site. The risk was there was a couple of stockpiles as well. So with the tool, you have the one-touch stockpile. So you simply click on that point, you put create a point right in the middle of it, and then it will automatically do a boundary around that, and then, or you can do automatically, and it will select all the stockpiles on the site with boundaries around it as well. And then what it'll do, create your surface model from that, which is pretty handy. And then with that surface model, you can then, it gives you the ability to calculate. So you just simply hit calculate volume. So all your stockpiles will be listed in there on the right hand side, listed all your stockpiles there. You hit calculate, and once you hit calculate, it'll calculate all the volumes. And then once done with that, you can simply create a report, and it will output your reports for you instantly in there. So a very powerful application, and it's designed especially for the survey and mapping. And this create all the features that you want. So at the end, what you get is a site where you can extract trees, do your contouring, identify your buildings, do your surface models, and then you are sure to have accurate data. You could also do some drafting on that, create a plan straight in the TBC software, and then output that to your client with all the relevant information. So then again, I'd like to restate that with the Wingtra, it allows you to do maximum efficiency. So you're very efficient. You don't have boots on the ground going out collecting data. It's reliable insight. So you can see the data was reliable. I looked at the accuracy versus my checkpoints, and it was within the tolerance. Simple workflow going through the WingtraOne, the Wingtra pilot, Wingtra hub, and then Wingtra Lidar, and then you got your last file. Simply take that file, put it into your third-party software package, and start creating your deliverables. The coverage, large coverage, a lot of coverage. I mean, 360 hectares in one flight at 90 minutes, 30% overlap, no calibration required. A lot of these drones is that when you put it on, it goes up in the air. It has to go back and forth doing calibration. That's taking about 10 minutes, 20 minutes sometimes off a flight. If you only have 40 minutes battery on there, you really and truly only have a 20-minute flight. And then if it's not going the speed as which the Wingtra is going, the area, you can't cover that amount of area that you want. So these are some of the things that you take away from that. These are some of the points you take away from it. No strip alignment, so very little work to do in the Lidar app. As you saw, you click on the front, the start and the end of the strips, and then you save that information and you export. Okay. Thank you very much, and this is it for me. And thank you very much for your time. And any questions, guys?
We have a couple in the chat, Darrell.
Okay.
So the first one, which I think you just briefly touched on, but still a very good question, is about how thick dense vegetation crop can be penetrated. So These I might go first if you want, Darrell, then you can
Yeah,
add
go
on to
on,
it.
go on, go on,
Yeah,
then.
okay. So it's an excellent question, and obviously the lidar sensor, like the laser beam, are not penetrating like the leaves itself themselves. They just can go fill in between the gaps, obviously. So the tighter the gap, arguably you can say like the less data is collected. However, we have seen this solution to be quite effective in fairly dense vegetation. So even where you can still walk through the forest, but the vegetation is still quite dense. If you cannot walk through the forest at all, so you have a lot of bushes on the ground, up to half of the height of the tree, or maybe even just partially, then yeah, there could be some challenges in terms of collecting data in that environment. But generally speaking, we have seen for most use cases with forested areas, you can get valuable insights and still a lot of points or enough points to get a very good idea of the ground underneath the vegetation. We also have a data set of a forest available on our website, and that might give you an idea of what sort of in what sort of environment we have collected data, and it's possible to get the high quality outputs. And that forest is fairly dense. It's not just a line of tree or anything like this. So I'll recommend checking out that data sets on our website as well. Anything would you like to add, Darrell?
I think you covered all the information. I think.
Okay. Then in that case, next question is, what is the flight time for the Wingtra with the lidar payload? Very good. So you might have seen some stats that were on the slide. So we have, like, for example, 59 minutes flight time for the RGB camera, RGB 61. With the lidar, because it's the heavier sensor, we have a flight time of 35 minutes. So that's the difference in there. Because you have less overlap compared to an RGB, you still get, within that time, you still get the area coverage that we mentioned before in optimal conditions. There is also a question about the data. So can we get the trunk size data? Is maybe about the extraction of features, this question? Should this maybe, Darrell,
Yeah, well, with the trunk size, I don't think you will get trunk size. You could you could use it as a variable for doing your classification. So any trunk size, but I wouldn't rely on the trunk size data. I think you need more of a terrestrial scanner for that type of trunk size information. It'll be more accurate. When the trees are very small, so if you're looking at new trees, for instance, there were some trees in the Huntington site near the buildings that were just recently planted, and they were too small, and obviously it was also in it's also winter, so the trees didn't have any much foliage on those trees, so it wasn't it didn't pick them up very well. So I wouldn't guarantee for trunk size information for trees.
Yeah, we have seen some. Yeah, the trunk itself, I agree, can be challenging. We have seen some good insights though in terms of the size of the canopy, so the crown, and also like the height of the trees. That's something that it can be extrapolated, so that there's information. And but yeah, as Darrell mentioned, we it's airborne data, so coming from the top. So while we get information still about the height, and we can have a visual of the trunk, yes, it depends how good and accurate the data needs to be. So as Darrell mentioned, like, might need assistance from ground systems too.
You're looking at the agricultural application. I think it's all determined on the height at which you fly. So if you're looking at agriculture, I'd say probably you will need to fly lower in order to get that detail of the crop soil. Again, as Lorenzo said, that if you can't walk through it, or there must be a way of the light penetrating the foliage to get to the soil. And these are the things. I mean, in some areas you probably will get it, because I have surveyed a few crops like wheat, etc., you do have times where you can see the soil and get a little bit more information in there. But yes, you would need that. You would need to fly very low in order for you to get that.
Okay, that I think was the last question in there, right? I think there's one more about biodiversity research to know vegetation elements. And then photogrammetry versus LiDAR. So it's a very good question. So if there is a requirement from your project to actually have a visual, representation of the features that you're capturing, but meaning that you can identify differences via color, then the better tool would be photogrammetry rather than LiDAR. LiDAR will give you an output, which is a 3D model, but it is not. We can colorize that. We can add photogrammetry data to it. But if the only requirements that you have is like to identify, for example, like different colors of plants or other items just visually, then photogrammetry will still be probably the best tool, the better tool in this case. Would you like to add anything, Darrell, to that?
No, I think you're correct.
Okay, no problem. So yeah, and to add to that is a specific tool or different tools for certain use cases. So LiDAR can be very helpful in vegetated areas, to get data underneath. Photogrammetry still is very valuable for cases where you don't have vegetation, or in this case, as I mentioned in the question, it's very important for you to get information about the features like color and in there. So it's that's where like having both, it can give you, depending on your project requirements, it can give you a lot of flexibility. Any other questions?
There are some case studies on the Wingtra website, and if you want, I can also provide you links to that, which show surveys in very highly vegetated areas, and this will give you an idea of what deliverables are in these highly vegetated areas. So, how much penetration you will get through the foliage based on that. So, hopefully I'll provide that link to you, or we could provide that link to you guys, and then you can have a look at yourself.
Yeah, that's an excellent point, Darrell. And depending, we do have a ton of case studies on our website collected, over the years, and for a variety of use cases. So from like ag applications to forestry to more traditional like construction projects, monitoring stockpiles, mining, using all our sensors that we have up there. So very good point, Darrell. Definitely, it's worth checking that out.
Okay. All right. There are no more questions. I'd like to thank everyone for taking part in the in this webinar. Coming online, we appreciate it. If you have any questions regarding the Wingtra or the payloads, or you want to have some sample data, please feel free to contact myself, and we'd be happy to provide that information. Also, if you have sites that you probably will want a demo, or you're interested in seeing the product live, please reach out to us and let us know, and we would be happy to facilitate that.
Okay, I thought it was just another question coming, but just a thank you. All right. No problem. It's holding on for the last few minutes just to say there was one there. Okay, perfect.
All right. Thank you, guys. Thank you, everyone.
Thank you. Thank you so much.